Imagine you're at a casino, engaged in a simple coin flip game. The odds are slightly in your favor. You win 55% of the time and lose 45%. You decide to play 100 rounds, but here lies the critical question. What are the chances you'll walk away with a profit? Your instincts might suggest you have a good shot at it because your winning percentage is higher than your losses. However, even with improved odds, losing money is still a possibility. The reality is that the outcome of your 100 games feels random and unpredictable, so how do we determine what's likely to happen? Enter the Monte Carlo simulation, a powerful tool that uses repetition to make sense of randomness. Contrary to what you might think, this method isn't named after the luxurious casino in Monaco, despite the fitting connection. Today, I will illustrate how tapping into randomness can help us predict outcomes. We will utilize our simple casino game to uncover hidden patterns through thousands of virtual trials. By the end, you'll grasp how scientists and analysts solve complex problems without getting bogged down in intricate math. Let's set the stage for our game. Imagine flipping a special coin that grants a 55% chance of winning and a 45% chance of losing. Each win nets you $1 while each loss deducts $1. Playing 100 rounds leads us to explore the probability of ending up in the green. While it seems straightforward to figure this out, after all, you win more than you lose, the randomness can still play tricks. You might experience bad luck with a streak of losses or, alternatively, get lucky with a winning run. Each individual attempt yields different results, making predictions tricky. One game could conclude with a profit of $10, while another might end in an $8 loss. The results appear scattered. This is where the magic of Monte Carlo simulation unfolds. Rather than relying on complex math, we'll embrace repetition. The premise is simple. One game gives us a somewhat chaotic result, but many games reveal clearer patterns. Let's begin by simulating our 100-round game once. After 100 flips, let's say I end up with 53 wins and 47 losses, resulting in a profit of $6. But does this single game tell us anything reliable about our chances of profit? Not at all. If I played again, I might face completely different results. This randomness clouds the big picture, which leads us back to the strength of Monte Carlo simulation. Instead of one round, imagine playing thousands of them and tracking outcomes. Let's simulate our game 10 times. Game 1: 53 wins, 47 losses, a profit of $6. Game 2: 48 wins, 52 losses, a loss of $4. Game 3: 57 wins, 43 losses, a profit of $14. Game 4: 51 wins, 49 losses, a profit of $2, and so forth for a total of 10 games. Out of those, we made a profit in 6 games, suggesting a 60% chance of profit. However, 10 games don't provide solid confidence as results may still fluctuate. So, let's ramp up to 100 simulations. If 62 ended in profit and 38 in loss, our odds of making a profit rise to 62%. Now that feels more dependable. But we can enhance our confidence even more by running 1,000 simulations. Suppose we see 643 profitable games, giving us an estimated probability of 64.3% for profit. As we increase our tests, the estimates stabilize. When we hit 10,000 simulations, perhaps we record 6,427 profitable rounds, maintaining our chance of profit around 64.27%. This shows how the number is becoming increasingly consistent. Now, let's push to 100,000 simulations and observe if we can refine our estimates further. With 100,000 games, if we find 64,251 profitable outcomes, it translates to a 64.251% chance of profit. Finally, after running a million simulations, we might reach 642,487 profitable outcomes, leading us to a 64.2487% chance of profit. Notice how our answers converge toward a stable value, underscoring Monte Carlo simulation's reliability. This method allows us to answer complex probability questions without intricate math, and it also reveals the range of possible outcomes. In our million simulations, we can gauge the highest profit, the worst loss, and even the average outcome, confirming expectations around a $10 profit while showing the risk of loss. Monte Carlo simulations' versatility extends to various fields: business, engineering, finance, and environmental science, all leveraging its potential to navigate uncertainties. The takeaway today is clear: through simulations, we transform unpredictable randomness into predictable patterns, enabling informed decision-making. When faced with uncertainty, consider this method. It empowers you to model situations and uncover insights buried beneath chaos. If this exploration resonated with you, hit that like button, share with those grappling with uncertainty, and subscribe for more enlightening content.